Welcome dear students, myself Purushottam Pathak. Today I will explain you Congruence of Triangle, that is chapter 7 of NCERT Maths for Standard 7. Come to the Congruence of Triangles. Before Congruence of Triangle, to understand the Congruence of Triangle, we need to learn about a few things like congruence of plane figure. Say, assume that this is a book and there is another book. If the length, assume that length of this book is L and B and length of this book is also L and B. If you pick this book and put over this book so that the book is completely covered up, you will realize that no other part is visible outside. That means this book covers completely to this one, or this book covers completely to this one. That means if two plane figures, see the first thing, that is congruence of plane figures. In plane figures, if two figures are there and both the figures are exactly, that means one figure covers up another figure without bending, without twisting or without stretching. If one of the plane covers the another completely, without twisting, stretching or bending when put over each other. When put over one another, you can say, then they are congruent. A very simple example I can show you for this. If you take one matchbox from take out from matchbox and another matchbox from the same box, from the same packing, if you take out two matchbox and put one matchbox over another, you will realize that another matchbox or no outer boundary of another matchbox is visible because both of them are congruent. Similarly, if you take two biscuits, two blades, all of them are congruent there. Come to the another thing, that is congruence of line segments. To understand the congruence of line segment, we don't need to look at the thickness of the lines, because in a line only length of the line is considerable. So if one line segment AB is there, that is 5 cm, and another line segment PQ is there, that is also 5 cm. In this case, we can say PQ AB equals to PQ, line segment AB is equal to line segment PQ. In this case, we can say line segment AB and PQ are congruent as their lengths are same. As their lengths are same, or they have same lengths. In case of this was congruence of line segments. I explained you about the plane first. In case of planes, if we put one plane over another, it will completely cover up. In case of line segments, we will take the measure of both the length, measure of length. If both the lengths are equal, then both the line segments are congruent, otherwise no. Come to the congruence of angles now. Say this is angle ABC. This angle measures 55 degree, and this angle is PQR. I have drawn this side longer, this side shorter. Here I tried to draw this side longer and this side shorter, but measure of the angle is 55 degree. If in case of congruence of angles, see angle ABC equals to angle PQR, that we can say measure of angle ABC, M angle ABC is equals to measure of angle PQR, that is equals to 55 degree. Two angles are congruent. They are congruent now if their measures are same. You know very well that length of the side in a triangle does not matter. That's why if the measure of the angle matches, then both of the angles are congruent. Now come to the congruence of triangles. To understand the congruence of triangles, we need to understand several conditions that I am explaining you. Learn these conditions or criterion carefully, because it will be required in the 8, 9 and 10 as well. So to understand the congruence of triangles, first of all understand the criterions. How many criterions are there? There are 4 criterions at your level. That is, first one is SSS, second one is SAS, third one is ASA, and fourth one is RHS. I will explain you all these conditions technically here. See, if 2 triangles are there, say this triangle is A, let me draw the triangle clearly. A, B, C, and this triangle is P, Q, R. In those triangles, in both of the triangles, if measure of angle AB is equals to angle PQ, that means AB equals to PQ, AC equals to PR, and BC equals to QR. In this condition, see, all these things are matching. We can write 6 congruence criterions here, congruence conditions here, because in this case triangle ABC is congruent to triangle, this is the sign of congruence, congruent to triangle PQR, and when they are congruent, then we can say AB side matches PQ, AC matches PR, and BC matches QR. Similarly, angle A matches angle P, angle B matches angle Q, and angle C matches angle R. Once we get that two triangles are congruent, then all these parts are equal. So these are known as CPCT. CPCT, that is corresponding parts of congruent triangles. See, once you realize two triangles are congruent, then you can say that all these parts are matching. Now, this was the first condition, S, side, side and side, side, side and side. All these sides were matching. So I explained you the S. Come to the another one condition, that is SAS. According to SS condition, we got that if all the sides of a triangle is equals to, all the sides of a triangle are equal to the corresponding sides of another triangle, then both of the triangles are congruent. But in case of SAS, say two triangles are once again there, ABC and PQR. See, S means take one side, A means any other angle after that. S means this and A means another angle, and at S means after that one side. This side, this angle and this side. Similarly, this side, this angle and this side. If corresponding sides, that means AB is corresponding to PQ and angle A is corresponding to P and AC corresponds to PR. If corresponding two sides and included angle, that angle must be included between those two angles. That means if this side, this angle and this side of this triangle matches with this side, this angle and this side, then they won't be congruent. If these two sides and included angle, these two sides and included angle are, then only they will be congruent, as corresponding sides and corresponding angles must be equal to be congruent. So according to SAS condition, AB equals to PQ, angle A equals to angle P and AC equals to PR. Then we can say triangle ABC. Then triangle ABC is congruent to triangle PQR, and while naming the triangles, that is also remarkable. The first alphabet is A, matching P is there. So first A, first P. Second is B, so second matching is Q. So second matching B with Q. And third matching C is with R. So we had put here in accordance with the order. Now come to the third condition. In the second condition it was explained SAS. Now in the third condition, that is angle side angle. What happens here? See, if one triangle is there ABC and another triangle, once again I have taken PQR, angle side angle means assume this angle, this side and this angle of this triangle matches with this angle, this side and this angle. That means corresponding angles and corresponding sides. That means the side which matches must be included between these two angles which are matching here. Then if you take this angle, this side and this angle on this, and this angle, this side and this angle, then it will not work. So it will be if angle B equals to angle Q, BC equals to angle QR, and angle C equals to angle R. Then we can say triangle ABC is congruent to triangle PQR. This was the third condition. Now come to the fourth condition. In the fourth condition, it's RHS. By the name it's clear, R means right angle. Right angle, H stands for hypotenuse and S is for side. So of course we need to draw two right angles. In a right angle, the side facing to right angle is called as hypotenuse, or this one is hypotenuse. If this hypotenuse is equal and right angle is equal, R is there, that means right angle, of course both the right angles are equal, they measure 90 degree, and hypotenuse is there, hypotenuse is equal. If either of the side matches, this side is equal to this or this side is equal to this. For example, I have taken this side matches this side and hypotenuse matches hypotenuse. Then we can say our right angle. Let me name this triangle as ABC and PQR. Here angle A equals to, not angle A is not required because we need only the right angles. And right angle was here, angle R equals to not it is angle R, right angle is angle B equals to angle Q, angle not angle, right angle, after the right angle it's hypotenuse, hypotenuse is AC, AC equals to PR, and side, any one side, I have taken here AB is equals to QR. Any one side matches with another side, then we can say triangle ABC is congruent to triangle PQR. After knowing this much, we can proceed to the exercise 7.1. Turn to the exercise 7.1. Look at the first sum. See. The congruence criterion that I had explained you regarding the lines, that will be applicable in the first sum. And I had told you that two line segments are congruent if their measures are equal. That means in the first number we will fill up the blanks. Two line segments are congruent. You will write up the complete statement if they have same length. If they have same length, then they are congruent. In the B number, among two congruent angles, one has a measure of 70 degree. I had explained you, if the measure of angles are equal, then they are congruent. Then the measure of other angle is, of course, that will also be 70 degree. Come to the C number. It is when we write angle A equals to angle B. I had explained you that angle A equals to angle B means measure of angle A is equals to measure of angle B. You can write measure of angle A, or in symbolic form you can mention M angle A equal to M angle B. Now come to the 2 number sum. Give any two real life examples for congruent shapes. For the congruent shapes, so simple examples I can find. Number 1, two biscuits of same packet. If you take two biscuits of same packet, you will realize that both of them are congruent to each other. And second example I am taking here, take two blades, both of the blades, two blades of not of the same packet. If you take two blades from anywhere, they will be congruent. Now after the two number, come to the third sum, that is, let me rub the board. In the third sum, that is also in the page number 137, in triangle ABC and triangle FED. Actually in triangle ABC and sign of congruence is there. Yeah, triangle ABC congruent to triangle FED. In this case, under the correspondence is given here as ABC matches FED. You are asked write all the corresponding congruent parts of the triangles. Corresponding parts of the triangles. See, angle A will be matching with angle F. First alphabet. Second alphabet. Angle B matches with angle E. Second alphabet. Third, angle C matches with angle D. Similarly, side AB, first and second alphabet, matches to first and second alphabet, side FE. Secondly, BC matches with second and third alphabet, so second and third alphabet, that is ED. And last one, AC, first and third alphabet, first and third alphabet, FD matches with FD. These are the corresponding parts of congruent triangles, that is CPCT. Come to the fourth one now. See, in the 4 number sum, triangle DEF is congruent to triangle BCA. Triangle BCA. Yeah. Write the parts of triangle BCA that correspond to number first. It was angle E. Angle E will be matching with, see, this is the second alphabet, angle C is the second alphabet. Similarly, side EF is matching with E and F, second and third alphabet, so it will be matching with side CA. Third is angle F is there. See, angle F will be matching with third alphabet is there, angle A. See, without drawing the triangle, I am explaining you. If you draw the triangle there, very easily you can locate them. And fourth one, DF. See the DF, D and F, the first and third alphabet will be matching with first and third alphabet, that is BA. In this way, you can write the congruent parts. I think that exercise 7.1 is over now. We will proceed to the exercise 7.2 also in the next class. Thank you very much.